Hey, amazing people. We're going to look at loans and how a geometric series can apply to loans. So we've got this example here where a man borrows $5,000 at an interest rate of 18% per annum, where the interest is compounded monthly on the balance owing. The loan is to be repaid in equal monthly installments. What should the amount of each installment be to pay off the loan in 4 years? Now, first thing we want to do here is we need to define a few things. So one of the first things I want to define is what the monthly installments are going to be, or a letter for them. So I'm going to let the monthly installments, first of all, I want them to be P. The amount owing after n months, I want to be $8. Now, this is critical as we start to work through this. Now, what we need to do is we need to start by establishing the pattern before we can work out the equation overall. And so what we're going to do is we're going to look at month one first. And as we calculate this, we're just using compound interest to get us started, but we're going to be evolving our equations as we go. So this is going to be $5,000 times 1.015, that being the interest rate here. When we divide 18 by 12, we get 1.5%, and then converted to a decimal and added to 1 is 1.015. And then in addition to this, what I need to do is I need to take off the monthly payment as well at the end of that. So that's the first month done. There's not a lot to do here. It's done. We've got it set up. So what we do now is we move on to month number 2. Now, in month number 2, what we're going to have, well, it's going to involve month 1. So that's starting first. So whatever we had at the end of month 1, that's going to be the first thing we've got. But then what we need to do is we need to times that amount by 1.015 to put the interest on and then remove our next payment. Now, for this one, we do want to start to rearrange things a little bit as it's going to help us in our later steps. So I'm going to expand the brackets we've got here, which gives me 5,000 times 1.015 squared. When I times that by 1.015, then it's going to be minus 1.015 times P, and then minus P. And I can even go a step further with this and factorize out P minus P, and that's going to leave me with, and I'm going to have 1.015 plus 1 here. So that's what we've got at the end of month 2. So let's go further. Let's look at month 3 now. So as we look at month 3, what we need to have is we need to involve what we had at the end of month 2, which is going to be 5,000 times 1.012 squared minus P of 1.015 plus 1. And now we've got brackets all around that. We need to times that by 1.015. And then minus the payment at the end of that. Now, again, we need to rearrange this. So I'm going to expand all the brackets first. I'm going to have 5,000 times 1.015 to the power of 3 now. Then I'm going to have the next part. And what I'm going to do here is I'm going to factorize out P, because it's in both instances here. It's in this and it's in this part here. So that's why I'm factorizing out P. Then in addition to that, I'm going to expand this into this bracket as well at the same time. So as I do that, I end up with bracket 1.015 squared plus 1.015, where I'm doing that times the 1 inside the brackets. Then I've got plus 1, which comes from this here when I factorized negative P from that. And so that's going to give me that. Now, this is helping me to establish the pattern here of what's happening. So from here, what I want to do is I want to continue the pattern, but I want to be able to jump ahead now, because the first one we have an idea. The second one, okay, we're starting to see it slightly different, but we can see the connection now by looking at these 3 here. And the connection is built in this here and this here in particular, where we can see that we've got that P outside of it, and then we've got what looks like a geometric series inside the brackets. In each of these points here, and that's what we're looking to capitalize on. So what we're going to have now is we're going to have a to n is going to be equal to 5,000 times 1.015 to the power of n minus P bracket 1 plus. Now I'm going 1 plus because I want to reorder what I've had down here so that I have it as a geometric series. So in this case here, it's going to be 1 plus 0.015 plus 1.015 squared. And moving on to that last point, it's going to be 1.015 to the power of n minus 1. Now, the reason it's n minus 1, if we come and look here, this was the 3rd month. and yet we've got to the power of 2 here. So it's 1 less than that period. If we look in month 2, we had this just to the power of 1. So it's 1 less than that month there. And so that's why it's going to be n minus 1 over here. So now what I want to do is I want to get the a to 48, because there's 48 months which we're dealing with here. And I want to substitute that value of n in. And that's going to be 5,000 times 1.015 to the power of 48 minus p, 1 plus 1.015 plus 1.015 squared plus all the way up to 1.015. And this is going to be to the power of 47, because remember, it's 1 less for here. Now, another key thing that we know is that we have a is 48 is equal to 0, because this is the point where the loan is paid off. So based on this then, what I want to do is I want to rearrange the equation I have here, since effectively it's 0 equals 5,000 times, etc. at this stage. So by rearranging it, I want to make p the subject, since p is the only letter which we have in this now. So it means we can solve it using normal algebra. So as we go and do that now, what we end up with is we're going to have p is equal to, now what I'm doing here is I've moved this whole equation to the other side of the equal sign by adding it, and then I'm also going to divide by this as well to move that back to the other side. And so it's going to end up as the denominator to this, which remains as the numerator. All right, so in this case here we have 5,000 times 1.015 to the power of 48, and that's going to be over 1 plus 1.015 plus 1.015 squared plus all the way up to where we've got 1.015 to the power of 47. So with this here now, we've got enough information to be able to solve for p. Now with this equation, what I want to do now is I want to focus on just the denominator here, because this is our geometric series. Now, when we have a geometric series like this, we can find the value of that. So what we have is S of n is going to be equal to, remember, it's a bracket r to the power of n minus 1 all over r minus 1. Okay, so using this plane here, that's what I'm going to do in this case. So in this case, at the moment, we've got a is equal to 1. We've got our r, which is equal to 1.015. We've got our n, which is equal to 48. Now remember, the reason it's equal to 48 is there are 48 numbers in this series, with the first one being just the number 1 by itself. That's why, even though we've got a power of 47, that is the 48th term in that series. So doing this now, we know sum to 48 is going to be equal to 1 bracket 1.015 to the power of 48 minus 1. This is going to be all over 1.015 minus 1. A little bit of simplification here. We get 1.015 to the power of 48 minus 1. And it can come out of the brackets because it's been expanded with the 1 out the front. And the bottom here will just be 0.015 once we subtract that 1 from there. So now what we want to do is we want to put this back effectively into this to do some replacement. So we're going to have P is equal to 5,000 times 1.015 to the power of 48. Now it's divided by, and I'm not going to represent it as a fraction here now because we've got this other fraction here, and that's going to be divided by 1.015 to the power of 48 minus 1 over 0.015. Now to better represent this, what I'm going to do is I'm going to flip this fraction upside down. So I have 5,000 times 1.015 to the power of 48. It's going to be times, in this instance, it will be the denominator now, which we're timesing by. So that moves to the numerator. So it's going to be 0.015. And then that's going to be over. And I can apply this to all these other parts here. This can be 1.015 to the power of 48 minus 1. So now once I go through and type this into my calculator, I can begin to work out the value of this. And what we will end up getting is we get $146.87. So to write our statement to break this up here, we've got each monthly payment or installment must be $146.87.